The joins we have done thus far are called inner joins, and the reason they're called inner joins, this goes a little bit with set theory. Basically, if you can think of the table on the left as a set of rows, and the table on the right as another set of rows, we want to know where these tables have something in common, and so we take where they meet in the middle or in the inside. If we had a Venn diagram, well, here, let me just find one. So here I have a Venn diagram, and you can think of each circle as this is the left circle is the table on the left, and the right circle is the table on the right. And so an inner join is where do these two tables meet? For example, well, let's see if we can write a little bit of Sql to demonstrate this. So if I say select contact name from customers, or select splat from customers, and then said select splat from orders. And then if we run and get the results of these two queries, the place where these two tables meet, well, for example, this row, Vignette, does not belong to AlfKI or Anatur or Anton or da-da-da-da-da. It belongs to Vignette. So the place where these would meet is, if I scroll down, on the Vignette row. So Vinzet, I'm not even going to try to slaughter that. Paul Henriette, his company made this order. So it's an inner join. We're basically finding where the two tables meet. Now I'm going to demonstrate a cross join, which is also called a uncontrolled join. But basically what a cross join does is it takes all the rows of the table on the left and pairs it with every single row with the table on the right. So I think this might be easier if we can find a table that has a little less data. Select splat from region. Let's just try that. Okay, so there's region eastern, western, northern, southern. So if I cross join the region table with itself, whoopsie, region. First of all, it's going to bring up an error because if you think about what's going to happen, Sql will want to put the region table on the left and the region table on the right, but the result set will have two region tables, which is ambiguous because they both have the same name. It's kind of like when I was in a class with my first name's Jamie, and it was often common for me to be in a classroom with several other Jamies, all being female. That was kind of frustrating as a child. Anyway, but everybody would say Jamie, 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 and they were never talking to me because I was not the popular one. It was always the girls. So our names, our first names, were ambiguous, and such is the case here. We have two tables. It's the same table, but since we're cross-joining them, putting one on the left, one on the right, we simply have two region tables. It's ambiguous. So a way to overcome the ambiguity is say as R1 and as R2. So now even though I'm bringing in the same table, I have some distinct names here. And if I run this, well, first of all, notice the cross join here. It's this eastern row, this one eastern, was paired with well, if we look here, let's order by R1 dot region description. So this eastern, the same row. Remember, let me pull in the region table again. Select splat from region. Okay, so here we go. So this one eastern row was paired by SQL Server with every single row in the table, including itself. So one eastern was paired with one eastern was paired with two western, the second row. One eastern was paired with three northern, see here. And one eastern was paired with four southern. So it's almost like we've multiplied these two tables together. In fact, if you notice, we have 4 rows. And so 4 rows paired with every other 4 rows makes 16 rows. Anyway, it's kind of called an uncontrolled join because, look, we uncontrollably smashed every row together. And honestly, this result set doesn't really make much sense if you think about it. Just dupe. Let's do something that might make more sense for a cross join. I am going to select splat from customers. No, I don't want splat. I want, let's do a contact name. Okay, execute that. Here's all of our contacts. Just to make it interesting, let's order by contact name, just to give us an alphabetical list. And then let's say our exotic food business. We wanted to turn it into a exotic dating business. Ooh, that sounds a little off color. Anyway, so we want to pair every customer with every other customer. We want to make all possible dating pairs we could have in our little online dating business. So the way we do that is pretty simple. We're going to select contact name from customers. I'm going to call this C1. Notice I could put the as here. You can actually leave the as off, and SQL knows what you're talking about. So C1.contact name. Cross join with customers again. Well, let's call that C2. And so let's do C2.contact name. Order by contact name. And now it's like, well, it's ambiguous. You have two contact name columns. So let's order by C1.contact name and then C2.contact name. Okay, so Alejandra. Looks like we have Alejandra paired up with everything, everyone, and Andre. So these are all of our possible dating pairs. Except notice we're going to have one slight issue. Andre, if I scroll up, Andre is eventually paired with themselves. So we don't want that. So let's do where C1 contact name is not equal to. Notice how we write not equal in SQL. It's greater than, less than, but not equal to. C2.contact name. So where they're not equal, so we get that. And so Alejandra is no longer paired with himself. But if you think about this, I have Alejandra, paired with everybody else except themselves. And then when I get, if you think about this, Alejandra, let's look at the next name in the list. So the next name in the list is Alexander. And Alexander is paired with Alejandra. But Alejandra's on the right this time. Go to the top. Notice we have that same pairing up here, except Alexander is on the right in this case. So whether it's Alejandra, Alexander, or Alexander, Alejandra, it's the same couple. So there's a little trick we can do to get around this, to remove duplicate pairs. We can just say where C1.contact name is less than C2.contact name. Again, that does a lexical, graphical string compare, basically on case. Let's run that. Now we have Alejandra Camino and Alejandra Fuhrer. But when we get down to Alejandra Fuhrer, down here, or Alexandra, sorry, we no longer have Alejandra because is Alexander, think of it this way, is Alexander less than Alejandra, which would have been on the right for that row? And no, that's not true. Alejandra is less than Alexander, but not vice versa. So we remove that duplicate couple. Anyway, that's cross join in a nutshell. Not too common to use it. You could do a cross join and a where instead of a join with an on. But the problem with that is a cross join first smashes all the rows together and then goes and filters them one by one by one, and it's a very expensive operation. Whereas an inner join with the on clause that we saw in the previous video, what it does instead is, instead of smashing it all together, it just says, well, will this row pair with that row? No. Will this row pair with that row? No. And eventually it finds all the matches and puts them together. So it's a little more, theoretically it takes much less time than a cross join.